Okay, last video we saw this formula saying that the number of permutations, that is arrangement where the order matters, is equal to n factorial over n minus r factorial, where n is the number of items available and r is how many you choose out of n to arrange. It worked when you have 4 and choose 3. Now, that's NPR. What we're going to do is look at what happened if you choose only 2 letters to arrange. First of all, let's try it with the formula to see what number the formula is going to give. We're going to pick 2 out of 4. So 2 letters out of the 4 available. What the formula would tell us then is that 4 available, permutations 2 chosen is equal to 4 factorial over 4 minus 2 factorial, which would be 4 factorial, as we saw, is 4 by 3 by 2 by 1 over 4 minus 2 factorial would be 2 factorial, which would be 2 by 1. So it's 24 over 2, which would be 12. Is this really going to work? Will it be 12? Let's see something here. We're going to choose only 2 letters out of the 4 and arrange them. Let's say we choose A. What's the next letter we choose? It could be B, or we could choose A then C, or we could choose A then D. Alright, that's what happened when we choose A first. What about choosing B first? We could choose B, then A, or B, then C, or B, then D. Okay, that's what happened when we choose B first. What about choosing C first? We would have C, then A, then C, then B, or C, then D. So that's what happened when we choose C first. What about choosing D first? We would have D, then A, or D, then B, or D, then C. That happens when you choose D first. There's no letter remaining for us to choose first. We've used up all the letters we have, A, B, and C, as the first letter. And for the second letter, we have A, B, A, C, A, D. There's nothing more. B, A, B, C, B, D. There's no other letter for us to put with B. Same thing for C and D. So let's count the number of arrangements we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12! It seemed to work. We saw that this formula that says N for P2, where 4 are available, and you choose 2 out of the 4 to arrange. The number of ways you can arrange these is 4 factorial over 4 minus 2 factorial, which is 12, and evidently it worked when we pick 2 out of 4. Alright, what would happen if we pick or choose 1 letter out of the 4? How many arrangements would we have? Let's use a formula to see if we could come up with an answer. Here we have 4 available to arrange. 1 would be equal to 4 factorial according to the formula up here, divided by 4 minus 1 factorial. 4 factorial is 4 by 3 by 2 by 1. 3 factorial, because this would be 4 minus 1, which is 3 factorial. So what we'd have is 4 by 3 by 2 by 1 all over 3 by 2 by 1. 3 by 2 by 1 cancel 3 by 2 by 1. The answer seems to be 4. Let's see. We are going to choose only 1 letter to arrange. We have A. Well, there's nothing more we can do. There's only 1 letter we choose. Then we have B. Then we have C. Then we have D. It seemed to work. There are only 4 arrangements. So this formula works. It is the formula that tells you the number of arrangements to make, that you can make when you choose R items and arrange from n available items. So remember now, it is NPR, where n is the number available, the number of items available, and R is the number chosen out of n available. So that's the permutations. We'll deal with the combination at a later date, so in a different video. So I'll see you then.